Welcome to the Bielik method, where today you are going to be learning how to solve a system of equations. That means we have two equations where we're finding the solution for x and y that would work in both of them. Now, I've taught you how to solve a system of equations using three different methods if you've looked at my previous videos, but today's problem is what I would consider a little bit more challenging than a basic level one. Okay, so in my first video of the substitution method, we already had a sticker ready. Okay, so I'm going to just pick up from there as if you've already watched that video, and we're going to lead right into this problem here. Now, if you look at this problem, one of the issues that I have is that I do not have a variable by itself. If I look at this x on this equation, there's a 3 attached to it. If I look at the y, there's a 2 attached to it on that side of the equation. This y has the -2 attached to it, while this x has a -3, and a +1 also on the same side of the equation. None of these variables have been isolated. None of them are all alone by themselves. Okay, so what we want to do is we want to choose one of these four to get all alone. Once we've done that, we'll have that sticker that we can peel off the board and plug in and cover up one of the variables for. So let's do that right now. Now I'm going to ask you to take a second and make the smart decision here. Okay, math is a tricky subject, and if you make poor choices before you start a problem, you're going to be beating your head against the wall. It's going to be hard, it's going to be difficult, and you're going to be the reason that it turned into that. Okay, so I want you to stop. I want you to ask yourself a few things. If you divide by 3 here to get x all alone, all you're going to make is a fraction with the y and a fraction with the 2. Now, I don't know about you, but if I can avoid those fractions, I'm going to do it. So what I'm going to look at is, first off, do I have any variable that doesn't have a coefficient, or in other words, a number attached to it right now? X has the 3 attached, y has the -2, x has the -3. This y is all alone. The only thing that is really making it so I don't have a sticker ready is that there's a +2 on the right side of my equal sign. Okay, that's my only issue. So if I can just get that +2 to the other side, we're golden, we're in check, and we can move forward just like we did in the previous video with any substitution problem. So let's do that. We're going to write 3x equals y plus 2. And I'm going to move that 2 over to the left side of my equal sign. Okay, that means I need to use my inverse operation. Opposite of adding 2 is subtracting 2. I would now be left with 3x minus 2. Oftentimes, I'll see students want to combine these, 3 minus 2, and turn it into 1. One of the terms has an x, while one of them does not. Therefore, we cannot combine those terms. They are what we call not like terms. Okay, I now have what is a sticker. I put my box around it. I'm going to picture myself peeling that sticker off. Now, if you look right here, that sticker is equal to a y, meaning when I put this sticker down on the paper or on the equation, it needs to cover up the y. I will no longer have a y written in this bottom equation when I write it out for a second time. I will now have -2. Instead of y, I'm putting down the sticker, equals 1 minus 3x. Now what we have done by using the sticker is we've eliminated the y variable. Now I'm dealing with nothing but x's, and when we have one variable in an equation, we can solve for that variable. It's an unknown, but it soon will be known. Okay, -2 times 3x, -2 times -2. Ask yourself, what's a negative times a negative? It's going to equal a positive through the distributive property. Negative times a positive is a negative. This is now equal to 1 minus 3x. I need to now get my variables to the same side. I could add 6x here, or I can add 3x here. The smarter choice, again, making life easy on you because math is already challenging and hard. Add 6x because now you're going to be dealing with positive values. If you would have added 3x, you're still going to get a negative result down here. Okay, so I now have 4 equals 1 plus 3x. We're now in a two-step equation. Okay, I'm going to subtract 1. 3 equals 3x. Now you should mentally know what x is by now, but if you need to show the last and final step, feel free to do so. Cancels, and x, I'll write it right here, equals 1. Now remember, with the system, you need an x value and a y value. Right now we're only halfway done, but the second half is not going to be as long as this first half. We're just going to take that 1, we're going to plug it in somewhere up here. Okay, if I put a 1 into either one of these equations, again, make a smart decision. Which equation looks easier to work with? I would absolutely 100% have to direct you towards the top equation. If I put a 1 next to that 3 times x is now 3 times 1. Okay, that's just going to give me 3 equals y plus 2. Again, you should be able to mentally solve for the variable here. But if you need to show the step, feel free to do so. That's why we practice this step. The opposite of adding is subtracting. Take away 2 from 3, and you're going to be left with your answer, your solution of y equals 1. Your x value is 1, your y value is 1. Therefore, your solution to this system is 1, 1. The only difference from this problem in comparison to my previous video where we did the substitution method, aka the sticker method, okay, the only difference is you didn't have a sticker ready. You now had to find y by itself to have a sticker. Once you found that, you go through everything else in the exact same order and the exact same steps as you would any other system of equation problem. Thank you very much for watching, and hopefully you are passing your upcoming systems test.